software that doubles the speed of 3D printers. Doubles. Let me explain the big problem that we're trying to solve. This is an example of a 3D printer. Everyone in this room knows that. Makes all sorts of parts. But you might not know that additive manufacturing suffers a couple of problems with respect to subtractive manufacturing. That's speed and quality. And in fact, in our customer discovery, we've found from end users that about 20% of the parts that are printed actually fail and have to be thrown away. One of the underlying reasons for this is vibration. Let me show you an example. This is a model of the Washington Capitol that was printed in 4 hours. So it's a good quality print. When we speed up the printer vibrates, creating here what we describe as layer shifting. Now this part has to be thrown away. Wasted time, wasted materials. When you install Ulendo software on the controller of the 3D printer, we achieve the same quality in half the time. How do we do this? We have developed vibration compensation software. We sell this software right now to 3D printer manufacturers. We first do an implementation process with them for a specific printer model, and then charge them an annual fee based on the price of that printer model and the sales trajectory. The benefits that we offer them now is that they can offer to their end customers a printer that prints twice as many parts of the same quality. Now for them, that means that they can either sell more printers vis-a-vis their competitors, or they can increase the price of their printers to accommodate the increased functionality. Right now, we are laser focused on selling this software to 3D printer manufacturers. But the complete scale of the company, the complete financial picture of the company includes adapting the same software to work with the millions of printers that are already out in production in the world. And then layer on top of that, the big market for us, adapting the same software to deal with industrial robots. That particular market has the same vibration issues, and it's over 5 times as big as the 3D printing market. So our typical exit strategy, our most likely exit strategy will be an acquisition by one of these 3 players. An additive manufacturing company. These 3 listed here have a track record of doing acquisitions. In our next market, we could also be acquired by the manufacturer of industrial robots, and we're focusing on cobots, by the way, on that market. And then also another possibility is a broad company that offers a portfolio of technologies for manufacturing automation. In closing, I'd like to share with you the overall vision of the company. We're actually striving to become the industry standard for speed and quality in 3D printing. Similar to Intel's ingredient branding, our vision is that Ulendo will be associated, or supercharged by Ulendo, will be associated with increased quality, increased speed, at a lower price. We hope you agree that Ulendo provides a great investment opportunity. Thank you.
Thank you.
Floor to the judges.
Good presentation, and I have 2 questions for you. So first of all, how do you integrate the software with the existing hardware for 3D printers? And the second question is, what gross margin do you anticipate to generate with the software?
Yes, so on the first question, basically our software is embedded alongside the firmware on the controller. So it's an additive. And right now we've perfected the implementation of our technology with Marlin. Marlin happens to be the most predominant firmware used in 3D printers. We'll be turning to the others right after we finish with perfecting Marlin.
Great presentation again.
Can you share more about how your solution integrates with the mobile robot technology and your strategy there?
Yes, mobile robots. So I can talk about cobots. So cobots are robots that work right outside in the unit. And we chose that as the entry to the industrial robots because of so much attention that's been surrounding it, and it's those cobots are dealing with some of the labor shortages that we're experiencing. So essentially, for adapting our algorithms right now that are designed for 3D printing, we have to add two factors. Number one, the payload of the robot, which you don't have with 3D printing, and also the profile of the robot, how it's, it's usually arms, how it's positioning. So that we're adapting our patented, I didn't even mention that, we have patents on our 3D printing algorithm for defining the vibration profile. We will adapt that to the industrial robots and pursue a patent on that as well.
What percentage of the 3D printer universe is this product applicable to? Is it all legacy 3D printers or also future in development 3D?
Yep, excellent question. So our technology is suited to the 3D printers that have moving parts. So the ones that work with light, they don't apply. And for the folks in the room who know the acronyms, FDM, FFF, DED, and some laser powder-based fusion printers. That is 80% of the printers being used out in the market today. So we've got a lot of opportunity there.
And the competition that's maybe working on similar solutions, are you familiar? Can you speak to that?
Yes. The one other software-only solution, but I'm not sure if I made that clear. This is software only. You don't have to attach any kind of hardware to the 3D printer. The only other software solution is something called Clipper. It's input shaping. Input shaping techniques, however, because of the way they compensate for vibration, create problems, defects in rounded corners, as an example. So they introduce, input shaping is another software solution, but it introduces other quality issues. And we've talked to several manufacturers of 3D printers who tried to implement input shaping to deal with the vibration, and they turned the feature off because the end user said, no way. Now you're introducing more ringing, more corner rounding, so we're just going to print slower, which unfortunately is what most of the world is doing today to deal with this issue.
Maybe lastly, can you share a little bit more about the team and how many people are on board right now?
Yes, thank you for that question, because this is a great story. The founder of our company, Chinedum Okudere, is a professor at the University of Michigan in mechanical engineering. He was an engineer at DMG Mori, and he was responsible for getting the vibrations out of a very, very expensive CNC machine. He tried and tried and tried. He had all the resources he needed, but he determined that he really needed to do some deep tech research. So he left DMG Mori, came to the University of Michigan, created a lab, and through the assistance of students and PhDs and postdocs, developed the first algorithm that now is patented, and his lab also has additional products coming out of it. I met Chi when I was volunteering for Dave Brophy's venture capital class at the University of Michigan, and it was a pleasure being a mentor for their student team that was using Ulendo as the subject matter. And so it was a kind of a 3-month interview for both of us together. I was just coming off of another exit at the University of Michigan, Connecticut Labs Suite. That was another UMN spin-out, and we sold that company in July of 2021. Thank you.
Great. Thanks, Bridges. Thanks, Brett.